A very good morning to one and all. And in today's class, I'm going to explain how to construct the parsing table for the SLR parser. And here, after computing the closure of I and goto of I, and after knowing how many canonical set of items that we get from the given grammar, and then we will find out the first and follow function. Means here, in the last class, I explained that how to construct or compute the closure of I and goto of I. And after computing the goto function, then finally the canonical set of items are I0, I1, I2, I3, I4, I5, I6, I7, I8, I9, I10. That means from I0 to I10, we get the items from after computing the goto function from the given grammar. And now we need to find out the first and follow function for the given grammar. See here, all of you see the slide that I shared to you. And in the first column, write down the productions. In the next, it is in first function, and the next, it is in follow function. And what the productions that we are having along with the augmented grammar. That means we are constructing the first and follow function for the modified grammar G dash. Make a note of this. For the modified grammar G dash, we are constructing the first and follow function. So we are taking the rules like this: S dash tends to S, S tends to A tends to A, B, C, or A. A is having the two rules, and B tends to D, right? And what is first of A? Sorry, first of S dash. First of S dash is first of S. And what is first of S? First of S is first of A, right? And where A is in terminal, so directly we are writing the answer in the form of like this, in the set A. And for S, it is also the set A. And what is first of A? And up to now, we construct the first function for the S dash and S, right? And now we're constructing for the A. A is having two rules from the given grammar. A tends to A, B, C. A tends to B. And here in this rule, first of A is first of A. And we're having the another rule for this A, that is A tends to B. That means the first of A is B. The first of A is B, right? And first of B now. First of B is what the first appearing symbol at the right hand side? D, right? And it is first of D, where D is in terminal, so directly we are writing an answer like this D. These are the first output functions for the non-terminals S dash, S, A and B. And now check for the follow function and construct the follow function now for the productions. S dash tends to S, S tends to B, A tends to A, B, C or B, B tends to D. And now what is follow of S dash? Follow of S dash. At the right hand side of the productions, we are not having any rule with an S dash. So directly we are writing that S dash is the starting symbol for the given grammar. So we are following the rule number 1, just we are placing the dollar in the starting symbol of the given grammar. The starting symbol is here S dash. From the modified grammar, it is an S dash. So just we are placing the dollar. And now the follow of S dash is a dollar. And what is follow of S? Checking out which rule is having the S at the right hand side. And rule number 1 is having the S at right hand side. And in this rule there is no S, in this rule there is no S. And in the last two rules we are not having the S variable. So just taking this and making it as an B. And what the beta is here? Beta is an epsilon. If the beta is an epsilon, then what we have to do? Follow of S is equal to follow of S dash. The S dash is already computed. S dash is already, we compute the follow function. So just we are writing what the output of the S dash is dollar. So just we are placing the same output for the S here. That means the follow of S is dollar. And now follow of A. Follow of A. See here we are having two rules for the A. We are having two rules for the A. And first take this rule and make it this A as an B. For which variable we are constructing the follow. Variable in the sense it is a non-terminal. For which non-terminal we are constructing in follow. Just make that variable as an B. And this is an B, then what the beta is a capital B. Put aside that first of beta is equal to capital B. And now see in this rule, again this is an B. And what is an beta? Beta is equal to, directly it is in terminal small b, right? What it means is first of beta union first of small b. Here first of beta means first of capital B union first of small b. And if we are having the terminal, then we are directly writing the terminal as an output. And here first of B, what is first of B? It is an D, right? The first of B is an D. And D union, terminal B union, and now we need to we need to apply the function, that is fall of A is equal to fall of B rule. We need to apply the rule fall of A is equal to fall of B rule. That means fall of A is equal to fall of A here. Fall of A is equal to fall of S. And what the fall of S output? Dollar. That means small b, small d union, the terminal D union, the terminal B union, dollar. And finally, by merging all those, then finally the output of A is, in the follow function, fall of A is D comma B comma dollar. D comma B comma dollar. That's the answer for fall of A. Now, what the fall of B is? Checking out where the B in the right hand side of the rules. Here in the rule number 2, we are having B. In the remaining rules, we are not having any B. Just we are taking this one and underline the B and make it as an B. And what the beta here? Beta is an E. That means beta is directly giving an terminal E. So directly we are writing an E. And we need to follow the dollar, right? So here we are following or applying the rule like fall of A is equal to fall of B. That means what the fall of A here? Fall of B is equal to, we are constructing for the fall of B, right? So fall of B is equal to fall of S. And what the fall of S output? Dollar. So finally the output for the fall of B is E comma dollar. E comma dollar. This is the first and follow function computation for the given grammar. After computing the goto function, we need to find out the first and follow function. And then we need to represent a table like this, right? And now the next one is an most important construction step, that is parsing table, constructing and parsing table, right? And here the parsing table consisting of two columns. One is an action and one is an go to. Action, most important two columns. From the block structure, block diagram of the parsing table, SLR parser, there itself we can see that there we're having a data structure that is an parsing table. There we define two columns. One is an action and the other one is an go to. And see all of you here. And here initially how many canonical set of items did we get from the given grammar? After computation, 10, right? So putting a column like this, item number, and write down 0 to 10 numbers. Write down all the 0 to 10 numbers here. And in action we are defining only the terminals along with the dollars from the given grammar. And what the terminals in the given grammar? A, B, C, D, E. From the given grammar, these are all the terminals along with the dollar. These are all comes under the action part, action column. And go to consisting of only the non-terminals. That means S, A, B. A simple logic that in go to we are writing the left hand side of the variables from the given grammar. In action, we are writing all the terminals from the given grammar. Whatever the terminals we are having in the given grammar, we are writing all those along with the dollar, right? And this is the table representation with the three columns, one with an item number, the second with an action, and the third with an go to function. And action consisting of all the terminals along with the dollar, and go to consisting of all the left hand side of the variables, that is the non-terminals in the given grammar. And items are from the, after the computation, we can define how many items that we get from the grammar. So from the grammar, I get 0 to 10 items. So I am writing like this. And now, how to fill these entries? Once, see, for go to function, we are filling for the non-terminals, right? So first initially we will fill the go to function, and go to of the state, the item with the non-terminals we are going to check. Item with the non-terminals only. What it means is, see here with go to, in go to function with I naught, we done 1, 2, 3, 4, 5 go to functions. We perform 5 go to functions. In that 5 go to functions, and when at which place we perform the item with the, we perform the go to function along with an item with the non-terminal. We need to check it out. What it means is, and when we process the item with an variable, and which state we get, what the number of that state is. State in the sense what the number of that item number is. And here I'm checking out. See here in go to I naught with S, I get an I1. I get an I1. And this is the terminal, no need to take it. And here I'm having the another non-terminal, I0 with A. And here what I get a new item I3, right? And here I2. After I0 with A, these are all with the terminals. We are not taking these terminals. When we want to fill the go to function, when we want to fill the go to function entries, we are only checking out the item with the S, A and B. That's it. Right. See, at I0 with S, I0, item number I0 with S, we get an item number 1. When we call the function go to function, when we perform the go to function, there we get at I1. When we process it with I0 along with the S, right? So here we are writing only 1. Without I, we are representing as an 1. And see here, after S, what the variable we are having for the I0? After S, what the variable we are having? A. That means I0 with A. I0 with A. At the place of I0 with A, we need to fill that entry with 3 without I. Why? Because here we are having an I3, right? See. I0 with A, 3. That means we are checking the goto function. To fill the goto function entries, we are checking the goto function with the item along with only the variables, not with the terminals. To fill this column, we are only checking with the variables. And see here. And up to now with I0 with S and I0 with A is completed. And here it is B. We are not taking B is in terminal, D is in terminal. Now see, I2 with A. What the number here we're having? 6. See here. I2, item number 2 with the A. At go to A. Just write down 6 like this. Right? And after I2, it is an terminal. It is an terminal. Now, I6 with B. B is an non-terminal. B is a non-terminal, right? And what the item number that we get there after processing? After processing, what the item number it is? I8, right? See here. At I6 comma B, at I6 comma B, we get I8. See here. I6 B I8, right? And it is with terminal, it is with terminal, it is with terminal, and it is with no more rules that we are having, no more functions that we are having with the item along with the variables. So it was completed. From the overall computations, we check all the items and only we get these outputs. That means I0 with S is N1, I0 with A is N3, I2 with A is N6, and I6 with B is N8, right? That means it is item number 1, item number 3, but we are not taking with I. Just we are taking the numbers there. Just we are writing the numbers here. From the item numbers, we are just writing what the number it is. And we are filling the entries like this. And this is about an goto function for filling the entries of the non-terminals. Now, how to fill the entries for the terminals? How to fill the entries for the terminals? And in filling the entries at the column of the action for the terminals, here we need to use 4 basic operations. One is shift, another one is reduce, and the third one is an accept, and the fourth one is an error, right? And whatever the blank entries that we're having here, these are all comes under the errors. If you put an error directly or if you leave it, nothing will be happen, no problem. If you didn't fill the entry means no problem. Without filling the entry, what it means is if the entry is not consisting of any operation, that what it means is it is an error representation. It is an error representation. And see here. And once to fill the action path, initially by checking from the computations of the goto function, first what we need to do is action of, that is 1 comma dollar is always accept. First you need to fill this entry. First you need to fill this block. 1 with dollar is always accept. Make a note of this. 1 with dollar is always accept. And then checking from the given grammar. Now I'm checking for the terminals. Item along with the terminals. I0 with A. Which state I get here? Which item I get here? I2. But in place of this I2, at the part of the action, I am writing like S2. S2 means shift. I need to shift here. I need to perform the shift operation here. So I am using S2 here. In the place of I2, I am using S2. That means at I0 with A, there is a cell, right? In that cell, I am filling that entry with H2. And now, I0 with B. I0 with B. At item number 0 with B, in the action part, when I am seeing I0 with B, they were having a cell. They were having an entry to be filled. And that entry is filled with an S4. S4. What it means is shift 4. Shift 4. And make a note, all of you, when we are writing, when we are filling the goto function, goto colon, we are checking for the item number with the variables, and there whatever the item number that we get as an output, that we are only taking the number from that. We are only taking the number from that, and we are just representing like this. And from the terminals, the items along with the terminals, we are getting a new items, right? It may be a new item or an existing item. No problem in that. If we get an item number, when we're checking for the item along with the terminal, we get an item number right there. So what we are doing here is, in the action part, in the action column, we are taking them as an, we are converting or using them as an, in the place of I, we are using S. Why means, when we are implementing the input parsing, when we are implementing the parsing input string, there we are using the stack. There we are using the stack. So we need to shift and we need to reduce and we need to show it as a success. That means accept, or sometimes it may be an error. So to show the type of operations that we are performing there, we need to use these symbols. That means in action part, we are only using 4 basic operations. One is shift, one is reduce, one is accept, and whatever the blanks we are having, blank cells, all these are all the errors, right? So from where we are taking the shifts, from where we are taking the shifts means, when we are checking the goto function with item along with the terminals, whatever the item there we are having, that is converted into a shift operation. That means at 0 with A, I0 with A, I am having I2 there. But at the place of representing in the table, I am using it as an S2. I am using it as an S2. Why means, when I am performing an action of 0 and A, I need to shift. I need to perform the shift operation, right? So for that purpose, I am changing the number item to the S. I am changing the item I, alphabet I to the S when I am representing in the parsing table. And here 0 with B is an I4 there, but here when I am representing in the table, it is an S4. And 0 with D, I0 with D, it is an I5. And here I am representing with an S5, right? And whatever the terminals that we are having, when we compute the goto function, that means goto of I0 with A, we are having I2. In the place of I0 with A, you should place S2. And I0 with B, we are having I4. In the place of I0 with B in the table, we need to place S4. I0 with D, 0 with D means I5. That means we are placing there with an S5. And here we are not considering the non-terminals when we are filling the action part. Only the terminals we are considering here. So I2 with small b, that means 2 with b. There we are filling the entry with S4. Why? Because here it is an item 4. There we are filling with an S4. Just we are changing the item I alphabet to the S. That means we are making it to perform the shift operation. So I3 with B, at 3 and B, there we are having S7. That means shift 7. And see, I6 with B, again it is an I7. So there we are representing as an S7. And I6 with D. From the computation we are having I5. In the table we are using as S5. See, I6 with D, it is an S5. Right, is it clear how to use the shifts, how to use or how to write the shifts as alphabet here, and how we are taking the sequence numbers here? Right, is it clear? Instead of I, we are just writing, we are replacing the I as an S, because to perform the shift operator we need to use the basic operation shift. That's why we are using the symbol S here. And for every for every terminals we are having the output in the form of an item number that is replaced with the S shift number here. The number is same. We are not changing the number. We are not changing the sequence number. Just instead of I, we are just using the S. And with this filling of the terminals from item from the goto function along with the item and the terminal, we know how to write or how to represent the shifts in the cells, in their entries. And up to now we know how to fill the shifts and how to fill the accept. That means always $1 is accept, and the goto function of the item along with the terminals that we are having the output in the form of an item number. That item number, the alphabet I is replaced with the S, but we are not changing the number there. Just we are replacing here. Just we are placing in the table like this. And now how to fill the red juice? How to fill the red juice? And now see the follow function. See the follow function here. To fill the red juice, we need to take the output from the follow function, and it see the grammar here. From the given grammar G, and give the sequence numbers of this 1, 2, 3, 4, right? 1, 2, 3, 4. 1, 2, 3, 4. When the first rule is ended, in which item the first rule is ended with the dot operator. That means initially it is dot A, B, E, right? And at the right hand side, when it was ended the dot. That means initially starting from the right hand side, initially, and after performing some computations, then it becomes, after processing, then the rule becomes S tends to A, B, E dot, right? When the dot operator processes, and when we stop the processing of this production number 1, and we are checking in the goto computations. See, we are checking in the goto computations at item number 10. At item number 10, right? Which rule it is? Rule 1. From the production rule 1, it is an 1 rule. Make a note R1. And in which item the dot was processed? That means the dot was ended for that rule at I10, right? And go to the table. And this is the rule for S. This is the rule for S. Make a note. And now go to the table. What is the follow of S here? Follow of S is an dollar, right? In which item the dot was ended for the rule 1? I10. At I10, go to the item number 10, right? There we are having the rule for the S, right? What the follow of S is dollar, and go to at the place of dollar. There we are having an entry to be filled, right? There we are having an entry to be filled. It is in rule number 1, right? The follow of S is dollar. So R1, we are placing it as an R1. This is an output for the follow of S. Output of follow of S is in dollar. And in which item that rule was ended, that dot was processed at which item? In I0. So at I0, that is in rule number 1, and the follow of that S is in dollar. So we are placing here, right? And check it out. What the rule number 2 is? What the rule number 2 is? From the given grammar G, we are checking out. A tends to ABC, right? And checking out when this rule was, when the dot was processed at the end of this rule. At which item the dot was processed at the end of this rule. And this is rule 2, make a note R2. And here the rule starts with an A. That means we need to know what the follow of A is. And what the follow of A is, and this is in rule 2. And now I am checking at the computations of goto when the dot was ended for this particular rule. and checking there at I9, and go to the table at I9, what it is? It is in rule number 2, and the rule starts with an A. Now I am checking for what the follow of A is. Follow of A is D comma B comma dollar, D comma B comma dollar, make a note, or BD dollar. See here in go to in this parsing table at I9, BD dollar, that is in rule number 2, right? R2, R2, R2. Just fill the entries with R2, R2, R2. That is, this is rule 2. This is rule 2. This rule was ended at an item, processed the dot at an item I9, right? And for that rule 2, the rule starts with an A, and what the follow of A output is BD dollar. So in the place of these entries, just write down R2, R2, R2. Is it clear? How to write the reduce numbers? And up to now we fill the entries with the accept and the shifts, and now we're filling just by taking the outputs from the follow function for the reduce operation. Now from the given grammar, it is an R3, rule 3, right? It is an R3. A tends to B. When this A tends to dot B is ended, that means when the processing of the dot operator ended in the rule. See here, at I4, again this is also, the rule starts with an A. So we need to take the follow of A here. At I4, at item number 4, which rule it is? R3, right? Item number 4, the rule is an R3, and what the follow of A is? Again BD dollar. BD dollar is the follow of A. So just place R3, R3, R3 here. Write down like this, R3, 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 right? And what the fifth one? From the given grammar, what the fifth rule is? B tends to D. B tends to D. This is R4. Fourth rule is R4, right? R4. And when the dot was processed at the end of the rule? At I5. The rule number is an R4. At the place of I5, at the place of item number 5, when we perform the go to of I0 with D, we get a new state, new item I5, right? There the dot was ended for that rule. So at item number 5, the rule is an R4, and here the rule starts with the B, right? So we need to consider what the follow of B is. What the follow of B is? E comma dollar. And now go to rule number, which rule it is? I5, right? Go to item number 5, and from the grammar, which rule it is? R4, right? And what the follow of B is? E comma dollar. That means we are placing R4 and R4 here in these two entries, R4 or R4, right? Is it clear? This is the way of filling or constructing the parsing table for the SLR parser. And there are no more productions to be processed for writing the reduce operation. Why? Because we're having only the 4 productions from the given grammar. We check it out, all the 4 productions, and we fill the entries for that 4. So totally the filling of the parsing table, that means the construction of the parsing table was completed by writing the shift operation, by writing the reduce operation, and by writing the accept, and then finally the errors. The errors means this is a blank, whatever the blank says that we're having, we make that entries as an errors, right? This is the part of an action. The action part consisting of all the terminals from the given grammar along with the dollar, and the go to consisting of only the variables, that means the non-terminals. Items from the canonical set. After computing the go to function, how many items that we get there? So we are writing all those items like this, and checking out the items from the computation. What we are taking is, for the variables we are writing just the numbers. For the item with the non-terminals, we are just writing the numbers. But the items with the terminals, we are writing the shifts. Right? And checking out for writing the reduce operation, checking out when the rules are processed, at the end of the rule, and at which rule it was ended, and taking that item number and at that item number, just placing the rule number at the place of the output of the follow function of that particular non-terminal. Right? Is it clear? And initially, $1 is an accept. It's from the algorithm. It's from the algorithm we are writing like this. Is it clear? Is it clear how to construct the parsing table? And now I'm explaining the another most important concept, the continuation of this, that is implementation of the stack. Implementation of the stack. That means here I am parsing the input string by using the stack. Stack is a data structure here. From the block diagram itself, I know stack and the input buffer and the parsing table, these are the data structures here. So by using all these, I am implementing the stack along just by parsing an input string. See. And what the input string to be parsed is, I am taking this input string from the given grammar A, B, B, C, D, E, $. A, B, B, C, D, E is the input string. Now I need to parse this input string from the predictive parsing table, right? Initially the stack is an empty, though, so the stack contains with an 0. Initially the stack is an empty, so it contains an 0. And now what the action that I am performing, either I am using the action table or the go-to table, and what type of an action I am performing here. These are the 5 columns I am having. Make a note of these 5 columns. One is a stack, input buffer, action table, go-to table, parsing action. That means these 3 from the predictive parsing. This is from the input string that I taken from the given grammar. The stack is a data structure here. Just by with the implementation of the stack, we are parsing this input, right? Initially the stack is an empty. Now I am performing the action. 0 with A, 0 with A. Check it out. Item number 0 with A is item number 0A. What the cell consisting of here? The cell is filled with the entry S2. What it means is we need to shift here. We need to perform the shift operation. So in the parsing action, I write there shift. What I am shifting here? First, initially I need to shift the symbol from the input buffer to the stack, and then what the number here, what the number to be shifted to along with this. That means initially the stack is with an empty with 0, and after performing the action with 0 comma A, I need to perform the operation shift, right? So I am shifting this A and along with this 2 into the stack, onto the top of the stack. Now action of 2 comma B, what is on the top of the stack? 2. So here it is an B, 2 with B. Again we need to perform this shift. See here from the table, 2 with B, action of 2 with B, it is an S4, right? S4, that means shift. We need to perform the shift operation. What we are shifting this B. Initially first we need to shift this B and then shift the 4 on the top of the stack. And now the stack contains 0A to B4 and the input buffer is B, C, D, E, $. And now what is on the top of the stack? 4. Action of 4 comma B. Action of 4 comma B, that is from the parsing table, 4 with B is R3, right? Reduce 3. And what the third rule is from the given grammar? What is the third rule? Reduce 3 means it is the rule number 3. What is the third rule? A tends to B is the third rule. So we need to take the length of the RHS of the rule. That means here we are having only B. That here we are having an algorithm to be followed. First we need to map this rule with the when we are having the operation is when we are having the operation to be performed as an reduced. If you want to shift, just we are shifting. If you want to reduce, we need to follow these steps. It is from the algorithm. What it means is, first initially we need to map this with A tends to beta, and what the beta is length of the RHS. That means this is the length of the RHS. Here it is 1. Now we need to pop 2R. R is nothing, 2 beta, right? 2 beta, that is the length of the RHS is 1. That is 2 into 1 is 2. And we are popping this 4 and B. And after popping, now we need to perform the go-to function. And what is on the top of this stack after popping 2, right? 2. What the left hand side of the variable here? A. Go to of 2 with A. See in the table. Go to of 2 with A is 6, right? 6. Now we need to shift this A and 6 to the stack. We need to shift this A and 6 onto the stack. Now the stack consisting of 0, A, 2, A6. 0, A, 2, A6. Now I am performing action of 6, B. From the table, action of 6, B is S7. That means we need to shift. We need to perform the shift operation. Shift. I am shifting this B and along with this 7. Right? And the input buffer consisting of C, D, E, dollar. Now action of 7 with C. 7 with C. From the table, the 7 with C is S9. That means again we need to perform the shift operation. Shifting this C along with this 9. Right? And now action of 9, D. See what the 9, D is? R2. R2 is the rule number 2. What the rule number 2 is from the given grammar? It is A tends to ABC. A tends to ABC. And we are mapping this A tends to ABC with A tends to beta, right? Beta is the length of the RHS. What the length of the RHS is here? 3. That means we need to pop 2 beta. 2 into beta. That means 2 into 3. That is 6. Here we are popping 6. We are popping 6. 1, 2, 3, 4, 5, 6. Now the top of the stack is 2. Now the top of the stack is 2. Now we need to perform the go to function. Go to of this 2, this A. 2, this A. From the table, 2 with A is 6. Again it is 6. Now pushing this A and 6 onto the stack. Pushing that A and 6 onto the stack. Now the stack consisting of 0, A to A6. 0, A to A6. And what the input buffer consisting of D, E, dollar. Now action of 6, D. Action of 6, D. From the table it is an S5. So we need to shift 5. Right. We need to shift 5. That means shifting this D along with the number 5. And now action of 5, E is reduce 4. And from the given grammar, what the fourth rule is? B tends to D, right? And what the beta is here? Length of the RHS. That means here we are having only 1. The length is only 1. That means pop 2 beta. That is 2 into 1 is 2. We are popping this 5 and D. And the top of the stack is 6. That is go to off. Here we are performing. When we are performing the operation like and reduce, then only we are using this go to table. Then only we are using this go to table. Otherwise, we are not using this go to table. If we are only shifting, performing the operation like and shift, we are directly shifting. We are not performing the go to table there. Right. Make a note of this. And now what is on the top of the stack? 6. And what the A is here? B. 6, B is 8. Is 8 from the table. So we need to push this B and 8 onto the stack. Right. Now my stack consisting of 0, A, 2, A and B8. B8. Right, is it clear? Sorry, here there is a mistake. 6B8 is there. 6, make a note. 6B8. 6B8. And now E dollar. The stack input buffer consisting of E dollar. Now it is A action of 8, E. 8, E. From the table action of 8, E is S10. What the operation that we need to perform here? We need to shift, right? We need to shift this E along with the number 10. That means shifting E and 10, right? And here the input string in the input buffer was consumed and finally we reached to the dollar. And now perform action of 10, dollar. Action of 10, dollar. Action of 10, dollar means it is an R1. It is an R1. What the rule number 1 from the given grammar? S tends to A, B, C. That means the length of the beta is 4. The length of the beta is 4. Make a note. And here pop 2 beta. That means 2 into 4 is an 8. And here we're having an 6, right? We're having the 6. After A, we're having 6. Make a note of this. We're popping 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Means from A to 10, we need to pop. From A to 10, we need to pop. And what it remains in the stack? Only 0. Only 0. Now action of. Action of. See here. Action of 0 comma dollar. What the 0 comma dollar is? See from the parsing table, once all of you see what the action of 0 comma dollar is. What the action of 0 comma dollar is? See here. See here. And what it is left in my stack? Only 0 is there, right? Only 0 is there. And now I pop 8 symbols on the stack. Whatever the symbols that I am having on the stack, I popped all those 8 symbols and the stack remains 0. And now go to off 0 and what the A here? S. 0 with S is 1. So we need to push this S and 1 onto the stack. Now the stack contains 0, S, 1. And now action of 1 comma dollar. From the table, what the action of 1 comma dollar is? From the table, what the action of 1 comma dollar is? Accept. Right? It is accept. I think it is clear to you all. So this, in such a way, we need to process the input string from the parsing table. And 1 comma dollar is accept. So with there, we're concluding that accepted. Therefore, the given input string is accepted by the parsing table. So whatever the grammar we considered there for constructing this SLR parser, the given grammar is an SLR parser. The given grammar is an LR of 0 parser. We can write like this. We can conclude like this. Is it clear? This is the parsing implementation. Just by taking an input string with the implementation with the stack, I'll show you how the input was parsed by performing these actions. One is an shift operation, another one is an reduce, and then accept, and then finally it is an error. By the basic operations of these from the shift reduce parser, we perform the action table. Is it clear how to parse the input string? And now finally, the graph for the G dash. Graph for the G dash means if you write the rules, or directly we can take the item numbers like this. I0 with A goes to which state? I0 with small b go to which state? I0 with the small capital A go to which state? Like that we need to represent like this. That means initially the item number starts with an I0, right? My sequence of items starts with an I0. So this is an initial state. And my sequence number starts with an, ends with an I10. So I10 is the final state in the graph. So just I am representing a graph structure like this, and I am saying that it is a finite automaton. If you write the rules in the place of these item numbers, it is okay, or else if you didn't write, only you are representing with the item numbers like an I0, just we are taking them as an states, considering the item numbers as an states. It is also an correct process. And I0, I1, I2, I3, I4, I5, I6, I7, I8, I9, I10. These are the 10 states for representing the finite automaton. And here we are calling that as an go-to graph. That means from the go-to computation, we know that the transition path from one item to the another item. That means when I am calling go-to of A, when I am performing the go-to of A, and after processing what the new state I am getting there, or what the existing state I am getting there. So what it is means, there we can clearly understand that it is a directed graph. We can show it as a directed graph just by making the transition path from I0 with A goes to which item, right? So this is the representation of the graph. graph from the G dash. Why I am calling it is an G dash means here we are using an augmented grammar. Here we are using an augmented grammar. When we are constructing the parsing table, there at the time of filling the reduce operations, we are only considering the grammar G. Make a note of this. We are only considering the grammar G just by giving the sequence numbers of each and every production row. There we are not considering the augmented grammar for the reduce. Right? Why? Because in the parsing table, see here, in the parsing table, only we are considering the grammar G variables, not the grammar G dash variables. If we are considering the grammar G, if you consider the grammar G dash variables, then here we need to write the S dash, right? And this is for the grammar G. This is for the grammar G and the computations from the grammar G dash. Is it clear? Whatever the things that I represented here in the form of columns, and what the action consisting of all the terminals, and what the go-to consisting of all the non-terminals, and the items from the canonical set of items, and all the terminals and all the non-terminals from the grammar G. And when we are writing or filling the entries for the reduce operation also, there we are considering the sequence numbers of the grammar G. Make a note. And when we are representing the, or when we are drawing the graph structure like this, then we need to consider the G dash. Why? Because the I naught consisting of the augmented grammar. I naught consisting of the augmented grammar. This is not the correct graph, right? Because there in this graph there are some mistakes. So that's why just I am showing the representation, not I am explaining in detail. If you want an in detail explanation, means you yourself can easily draw the representation. Why? Because see, make the states I naught to I10, and I naught is an initial state, I10 is a final state. I naught with A from the computations, I naught with S goes to I1. Just make an directed graph to I1 and there put an alphabet S. I naught with A goes to I2. I naught with A goes to, again, it is a non-terminal A, I3, right? I naught with B goes to I4. That means we know from the item to the, by calling an item with an symbol, we know which state, which item the output is, which item it gives an in the form of the output item, or we can consider it as an output state here, right? By these computations, we can clearly understand the direction, the transition between the items, between all the I0 to I10 items along with the alphabets. Here the alphabets are all the non-terminals and all the terminals we are considering. Right, is it clear? Is it clear how to compute or how to construct the first and follow function, and then how to construct the parsing table, and then finally the construction of an automaton, or we can also call it as an graph, go-to graph for the grammar G dash. And this is the overall construction process of SLR parsers. SLR parsers. With this, the concept of SLR parsing technique was completed. In the next class, I will explain the other type of parsing technique. And by knowing how to construct the go-to functions, and by knowing how to construct the parsing table and how to implement the input string with the stack, that means how to parse the input string with the stack. If you understand all these concepts, then it is very easy to understand the other techniques under the LR parsings.